Hey there, my good friends. How you doing today? BTD5, episode 6 of Scienced. So we're going to talk about the origin of life today, and this is one of those topics that people tend to get kind of angry about, people tend not to like. So what I'm going to try and do is try and keep this as factual as possible, or tell you guys that this is mostly only a theory. This is not for sure what we think, but just according to logic, this makes sense to scientists and evolutionists and people like that actually study this type of thing. We can't prove it because it really is almost unprovable, but we can talk about it and just have things make sense for us. So that's all I'm going to talk about today is what makes sense to scientists and what we've theorized overall. So the origin of life. Before I can start talking about how the first life actually started, all cells and all viruses have this thing called DNA or RNA, and it's basically how their biological information is stored. How do you make a cell a cell? Well, it's just based all upon DNA. The DNA makes the cell a cell. The RNA basically makes the virus's parts and things like that, and then they put them together. It just works kind of weird, that DNA is actually the storage of every single ounce of information that ever could make a human or ever could make a giraffe or all those things, all those crazy things. That's what DNA and RNA is. So it's kind of difficult to understand how that can actually make that happen, but it does. 100% DNA and RNA, they make those things happen. They make the shape, they make the size, they make the different proteins, they make everything up. That's DNA and RNA for you. So, DNA and RNA are pretty similar overall. The only real difference is that DNA has one different nucleotide compared to RNA. Actually, RNA has this thing called uracil, while DNA has thymine. Not that it's that important or anything, but it is different. Also, RNA tends to be more one-stranded, and is most of the time double-stranded, with very few exceptions to that. Um, but mostly in viruses and stuff like that, you get RNA that can be double-stranded. And you can also get some single-stranded viruses as well, which is kind of weird, actually. Also, one more difference that's not very important at all is that RNA has this thing called ribose, while DNA has deoxyribose, and that's how it gets its name, deoxyribonucleic acid. And RNA is ribonucleic acid. It's basically just a different sugar. Nothing too special there, but just have to mention it. Also, one other important part that I needed to mention is that RNA is not very stable. So you have to keep in mind that RNA is not very stable, which allows a lot of mutations and stuff like that to happen, and that leads to basically more differences in life. If you have an RNA strand, it's going to mutate a lot, and oftentimes that's going to lead to a lot of problems. But it doesn't mean it's going to lead to a lot of problems all the time. It could lead to a benefit. And that's the cool part about DNA and RNA and biological information, is that even though something can make a mistake, it doesn't mean it's going to turn out to be bad. It can actually turn out to be good, which is very, very odd if you ask me. But it really just does make sense. Even though you have billions upon billions of times that you have mistakes that are bad, every once in a while you get one of those good mistakes. So how did life actually originate? Well, there's two technical theories for life on Earth. Life could have originated on Mars, and then an asteroid could have crashed into Mars, lifted some bacteria or some cells onto Earth, and then life could have started that way on Earth. But that also leads to the question, then where did life actually originate? Well, the same thing could have happened to Earth, actually, where life actually originated on Earth instead of actually originating on Mars. So you're kind of just eliminating a step by saying that. And I think, of course, that just makes it easier, but it doesn't make it true. But just to make it easier, we're going to pretend like life is starting on Earth today. But we don't know that for sure, by the way. So there are a ton. Let's go back in time, guys. Let's go back in time. Let's go back about 4 billion years, because that's the point at which we think that the first life started on Earth within, a couple 100 million years. We're not 100% accurate, but we are pretty close to knowing about when life did start on Earth. You can usually tell with rock samples and soil samples and not really fossils as much, but there are some fossil evidences of bacteria and stuff like that. Not quite as far as 4 billion years ago, but pretty darn close to that. So, how do you get from nothing to something? It's a very philosophical question. I mean, you go from no life to life. It sounds almost unreasonable for that to happen, but And in fact, that's a big reason that why people say that life couldn't have possibly evolved from nothing, because cells are just too complicated, and have all that stuff happen all at once. It's just unreasonable. Like, how could you just have that happen? Like, snap into existence and have a cell? Well, that's the thing. A lot of people are mistaken when they think that a cell just snapped into existence and just magically occurred. It didn't happen like that at all, guys. It's natural selection over time with RNA and DNA. So this is how life actually started. You have billions upon trillions, trillions times trillions of these organic particles in the early Earth, or anywhere in the universe for that matter. Anywhere in the universe where there is a bunch of organic particles, this could happen. We think organic particles are pretty much everywhere. They're located in comets. They're located on Mars. They're located on Earth. If they came in comets, they can be pretty much anywhere. Okay, guys? Organic particles are everywhere. They really are. And organic particles or organic compounds are what make up life. So if you have all these organic compounds just floating around pretty much everywhere, what's to say that life couldn't have happened somewhere else compared to just here? But that's also a little bit of a stretch because we have to talk about exactly how life could have originated here. We're going to talk about how the first cell could have originated. They're obviously going to be extremely, extremely basic, but when you think about the lifetime of how long they had to evolve and how long they could have naturally selected over time, you're dealing with a lot of time here and a lot of space. A lot of space. It doesn't mean that only Earth this could have happened, because we're talking about it because we live on Earth, and evolution and natural selection happened for an extremely long time to make us able to understand these things. But this could have happened anywhere else in the universe, billions upon billions of planets, trillions of stars all over the place. Anywhere it could have happened. So you have these little RNA strands, and RNA strands really like to bind together with each other. You have all these little uracils and thymines and adenines and things like that. They all just like to bind together. So just understanding that RNA likes to bind to itself. Little pieces of RNA like to bind to themselves. It's kind of cool in understanding how life could have actually started. So you have all these little particles that are binding to themselves, and the cool thing about RNA strands is that if you have trillions upon trillions of them, and you just have one of them that can self-replicate, then it's going to start self-replicating and outcompete all of the other ones. But let's pretend that like 700 little RNA strands not really learned, but were through mutations and random chance, were able to self-replicate, which is not that hard to think about. Self-replicating happens all the time, and just having those mutations happen out of trillions upon trillions upon trillions of these chances of it happening, just to have 700 of them happen, it just completely makes sense. It's all totally reasonable. So you have 700 of them. Now, if you have maybe 20 of them that are just going to basically self-replicate, but it doesn't work very well, and you have 500 of them where they self-replicate, but it's just terrible. They just make a bunch of mistakes and stuff like that. But all you really need is a couple of them. If you have like 4 or 5 of them competing, where you have a couple of them that self-replicate pretty well, 3 or 4 of them self-replicate, and they can do it pretty fast. Those guys are going to outcompete the other RNA strands. So if a couple of RNA strands that are outcompeting the other one, eventually one of them is going to win out. Or at least a few of them are going to win out. In the basically in natural selection, in competing against each other for these organic particles. So now you have a bunch, trillions upon trillions of these organic particles, after we go through a little bit of time here of them competing and self-replicating and all this. You have a bunch of these RNA strands that can replicate really, really fast and really, really well. And over time, the ones that have mutations and crazy things happen to them that make them replicate just a little bit faster, a little bit more effective, is going to get an advantage. And like I said, these mutations happen all the time. And because we have billions upon trillions of this copy, the good copy now, through natural selection, that all you need is a couple mutations in those good copies to make them even better, and those guys are going to outcompete. So that's how you get better and better RNA strands over time. It's not hard to... A lot of people, they don't understand this 100%, and they think it's just crazy that RNA strands are just self-replicating. No, it does make sense, and it does happen. RNA strands replicate. It happens, guys. So, over time, what had to happen was one random little RNA strand that self-replicates had to get enveloped in a lipid bilayer. And this is not far-fetched at all either, because in the early Earth, where there's billions upon trillions of organic particles, there's also a bunch of little pieces of lipids. And guess what lipids like to do, guys? They like to form together. And these little lipids combining together, forming a little circle, guess what they like to do? They like to form little circles because they like to combine to each other. So getting a little RNA strand, not even a circle, I mean a sphere. They like to form spheres and stuff like that because they want to keep binding to each other. So the lowest energy level that they can have is binding together to each other. And all you need is just a couple random, even just one RNA strand that self-replicates to get stuck in one of these lipid bilayers, and then it's going to start self-replicating and things like that. And that's basically how you formed the first cell. Now, if you think of all the random chance that had to happen for these things to happen, agreed. A lot of random chance had to happen, and it sounds a little bit crazy. But when you have trillions upon trillions of stars, and trillions upon trillions of planets, and just millions of hundreds of thousands upon thousands of square miles just on Earth compared to all of the other planets that this could have possibly happened on, it's not that crazy to think that through random chance these types of things happened. And that's basically how the first life started. You just have RNA strands that over time, through natural selection, get better and better at replicating, eventually get encased in a lipid bilayer, and that's basically how you form the first cell. And then those guys have an advantage over the other ones because they're protected from the outside environment because of this lipid bilayer. And those guys are going to reproduce more, and through time, over time, because of natural selection, you get better and better cells at staying alive and replicating faster and things like that. The ones that replicate the fastest are the ones that stay alive and reproduce more. And that's basically how we get the first cells, guys. Now, hopefully that makes 100% to you, 100% sense to you guys. And hopefully you guys can understand that this is sort of just a theory. It's not 100% accurate, and I'm not saying that this is 100% sure the exact way that it happened, but I'm also saying that this just makes sense to a scientist in how life could have originated, and things like that. And then if you're wondering, oh, how did it get from RNA to DNA? Well, basically, throughout time, eventually, they've probably used RNA can be turned into DNA actually fairly easily, and through random chance, of course, if you get some sort of mutation where DNA takes over compared to RNA, DNA is much more stable compared to RNA. It's going to mutate a lot less, and that's going to become your main storage of biological information, DNA, because it lasts longer, and it's basically not going to get mutated and stuff like that. And that's why the bacteria and humans and all these eukaryotic cells started using DNA instead of RNA. But that's all I got for you guys today. If there's any questions, please go down there in the comments and ask me. I'll try and answer them for the next week or so if there are any questions. Beyond that, I'm not sure I can go back here and read all the comments and keep trying to answer all your guys' questions. So thank you so much for watching. Hopefully look forward to some more BTD5 Science, and have a great day.